Okay, good morning, everybody. Welcome to Barnyards and Backyards Live. I'm Jeff Edwards from UW Extension, and our program today, I'll just introduce you a little bit differently today, Jeremiah. Our
Sounds good.
program today is by Jeremiah Vardaman, who's sometimes, most of the time, co-host, but today he is our victim on Barnyards and Backyards Live. Also want to acknowledge Jenny Thompson. She is operating in the background to keep us straight and push questions forward for us. If you are watching via Zoom, if you scroll over the Zoom product with your mouse, at the bottom there is a Q&A or a chat button or box that you can click into. If you have questions, please use those. If you are following us on Facebook Live, please use the comment box and ask your questions there, and Jenny will bring those forward, and we will attempt to get your questions answered. So our topic today is irrigation. And
Right. And in particular, irrigation in our pastures. So,
irrigation in our pastures.
right.
Perfect.
And
So
yeah, we'll talk irrigation in general. And so a lot of these topics can relate, right?
can cross over, right?
Yeah, we can cross over to gardens or that. Irrigation is irrigation. It just
All
depends
right.
on where we're at in crops. So yeah, let me get us going here. We'll see how much my computer wants to play today. There we go. Can you guys see that?
Yes.
Great.
Great. Yeah. So yeah, thanks, Jeff. And yeah, thanks everybody for joining us. So we wanted to talk about the ins and outs of pasture irrigation. As an extension educator myself, I believe Jenny and Jeff get the same questions, but we get a lot of times questions of just how do I irrigate? How do I manage this acreage? Maybe you've lived there for a long time, or maybe you're new to the state of Wyoming, or maybe new to owning a larger acreage, right? May that be an acre?
Or new to irrigation.
Or new to irrigation, right? Yeah.
People who move to Wyoming who've never irrigated before, you know, there is a steep learning curve if you are not familiar with how to irrigate.
Right. Yeah, that's sometimes the funnest conversations, right? Like the rain in the sky doesn't take care of all this for us anymore.
Wait a minute, I have to get water to stuff.
Right. So, but before we dive in and get started on in depth on the topic, there's two resources that I really like to highlight, and I would imagine these are already on the Barnyards and Backyards website, but if they're not, we will make sure to get them up there as links. But the one on the left is the Wyoming Small Acreage Irrigation Guide, and this is a fairly comprehensive irrigation guide for anybody that's new to irrigating, especially fairly sizable land, so anywhere from maybe a half an acre upwards of 40 to 100, 160. But again, even these concepts do transfer over to commercial crop or down into a small garden situation. So the
Correct.
concept's transferable at scalable size, right? But the irrigation guide, it's really a very comprehensive guide. It's really nice. It starts out with water law, then talks about water rights, and then it goes into how do I determine when and how much water I irrigate. And then the last part of that guide is actually talking about conflicts. How do you resolve any irrigation conflicts? I think it was Mark Twain that coined the phrase that whiskey is for drinking, water is for fighting. And that just has to do with anytime water is involved, people are going to fight over it. And it's going to become a bigger issue moving into the future. So
I think so too. So you mentioned water law. What are some key components that people need to know about water law and their rights to that water?
Perfect. So that gets us going with the whole presentation. That's the premise of everything that we build off of, right? So the biggest takeaway is the state of Wyoming owns all water within the boundaries of the state. So that can be surface water, right? So that's streams, reservoirs, snowpack, that kind of stuff. Groundwater, they own all the groundwater. They even own the rain that hits the roof of your house.
Yes. So just because it falls on your property doesn't mean that you own it, or just because it's below your property doesn't mean that you own it either. It's not included in mineral rights.
Correct. Correct. That's totally separate. And so the portion, so the state owns all water within the boundaries of the state. And then we permit to the state to get access to that water. So that it may be municipalities, may it be irrigation, may it be for domestic use from a well, anything that way. We have to have that permitted to have that right to utilize that water. And
Jeremiah,
then,
are those permits generated at the county level?
No, they're not at the county level. They're generated at the state level. However, the state has regional offices and field offices out in, and I don't believe they're in every county, but they're out in the state, so you don't have to go to Cheyenne to do it. Okay. Yeah, great question. So once you file a permit, that's what's considered your water rights, and the oldest water rights have premise on that water. And so you'll have some that are back in the 1800s, even here in Wyoming, that have water rights. So they would have first right to that water as it moves down the system before newer ones. So a 1890 water right would supersede a 1900 water right, as an example. So another premise to understand on water rights is that when you have water rights, and we're going to talk specifically now on irrigation, that water is adjudicated to the land, is what it is known as. So adjudicated water rights. And what that means is that water is attached to that acreage of land that it's supposed to be irrigating. Now, you can get into situations where people are irrigating more than what is adjudicated for on that property. And so there are certain situations where, so if somebody comes in and audits that water right, they can find out, oh, you're irrigating more than you're supposed to be. Then on top of it, if you get into dry years, that's probably the most likely that you'll find out that my water doesn't stretch as far as it used to. And those adjudicated water rights really restrict you back to that.
Yeah. So can people, I don't know if this is the correct term or not, but if you find that if you're short water, and you have a neighbor who's not using their water rights, can you trade for them, or can you buy those water rights for that year from them in Wyoming?
So it all depends on the irrigation system that you're under, right?
The district?
Right. So up here in the PAL area, if you're in an irrigation district, you call for water, and the irrigation district will give you that water if it's available. And then you pay for that additional water on your property. That's in a system where you have a surplus of water. So not every place is under an irrigation district. So in other parts of the state, it really works off of working with your neighbors. There might be a ditch rider on the ditch to give you water, and you can share water back and forth between the neighbors. The neighbors will tell you, hey, I'm turning off, you can turn on, and working through that. If you do have a ditch rider, working through that way. If you want the physical water rights, right? If you want to adjudicate more water to your land, it is a legal process. You have to permit the state.
Okay.
You can do it. You can transfer water rights. It takes time and it takes money, but it can be done. It's not the most simple thing from what I understand, but it can be done.
Well, I know at the end of this week in my area, our districts are going on limit water.
Yep. And so that would be that situation. So when you're limited to water, then you only get what you're allotted for your acreage or what's available in water supply. And so you can even fall below your adjudicated water rights. And that's where the first water rights get their fill and then the next down the line. So
is it usually is the water right tied to the land, or if you're a new landowner, do you have to petition for new water rights?
No, so the water rights are transferred with the land. So if you buy land, water rights move with that property. But you would have to petition if you wanted to expand those water rights, if possible. Or if you wanted to drill a well. If the property didn't come with a well and you want it for domestic use or for irrigation use, you'd have to file a permit at the state, and if it's approved, you could have that well. The other thing along water rights that a lot of people maybe don't know about, and where would you know about it, right? Unless you've dealt with this a lot, and most people don't, is something known as ditch rights. So ditches run all over property here in Wyoming, and they don't take the straightest path. They meander across properties and it seems odd. However, and a lot of times that ditch is following the contour of the land, and that's why they don't run in straight lines. There's other reasons for it. But just a point I wanted to illustrate is, just because you have a ditch running across your property does not mean you have water rights to the water in that ditch.
Nor does it mean that you have the right to fill that ditch in.
Right. You can't. Yeah.
I
Correct.
have a situation in my neighborhood right now where an individual filled in a ditch that was used for a drain, and there's no place for that water to go.
Oh, no. Yeah. And that's a good point too, Jeff, is so you'll have the head ditch is usually what it's called, and that's the ditch that's bringing water or supplying water to the property. And then in certain instances, there's a waste ditch or a return ditch is what they're called. And that catches the water at the end of the field and then takes that back to the source of the water. So it might be a river, it might be a drain tile, wherever that water's supposed to go. But it is the person that has the water rights and is irrigating, it's their responsibility to maintain that head ditch and their waste ditch from the point of source to the point of termination. So just because you have a ditch running across you does not mean you have legal right to the water, and does not mean you can fill or change or alter that ditch. And one of the biggest issues that I hear about is trees. People plant trees right along the ditch, and those tree roots fill in those ditch and back up water, and they fill in with sediment, and they're just a nightmare. And then we have water fights, just like this great,
just like your image.
So enough of that.
Okay.
But the big thing we want to get to is, why are we doing irrigation? What is the purpose of irrigation? Why do we even want to do it? A lot of times we do get people that have moved from out of state to Wyoming, and they don't have to irrigate where they're from, but they're in moisture regimes that are in 25 to 30 inches of moisture annually, or upwards of 60 inches of moisture annually. So everything just naturally grows in their area because they get so much moisture. One of the biggest reasons for irrigation is to augment or offset areas that do not have enough annual precipitation, or it's either to regulate that, to keep a constant supply of water in a place that doesn't, such as Wyoming, right? We're a desert. We're a high elevation, cold desert. And you can see by just this map, that buff and tan color is 15 inches or less of moisture annually. So that includes snow.
And that's about 95% of the state.
Yeah, that can be kind of depressing when you put it that way, Jeff. Come on. And you can see we do have some high moisture areas in the state, but they're most likely mountain ranges or tops of mountain, high elevation and that. So if you are adjacent to those mountains at the foothills or partway up those mountains, you might get 18 inches or 20 inches of moisture, but those are very small microclimate areas in the state. So the purpose of irrigation here in the state of Wyoming is to augment that lack of precipitation. But then on top of it, precipitation is not consistent or uniform or steady throughout the year. And so then to augment that throughout the year as well, so we have a more steady irrigation supply to our crops, so we have better crop yields. So this is what people really want to know when they call, right? That's all background history. You really need to know that. Very important. But this is what I want to know.
After they've figured out that they do have water rights.
And how much I have, right? When and how much water. That's, 100%. So that's this when and how much water do I need. That can be coined as your irrigation scheduling. So how do I schedule my irrigation around that? So it's not a simple answer. That's the first thing, the first caveat I want to throw out there. That irrigation manual that we talked about at the beginning, this chart comes right out of there. And so the first thing we got to understand is, what is the crop need or crop demand for water? And that changes based on the crop and then based on where you live. And so for a scientific approach to this, they use what's called evapotranspiration, and that's that other resource there. And we'll talk about that here in more detail in a little bit, but that publication will talk about that. But so they use, especially for our commercial crop growers, they use ET, or evapotranspiration, to estimate crop water use. And so this chart is based off of the number of inches of water per growing season per acre
that the crop it requires.
Correct.
Okay, so the other part of this that you might be able to see is that Sheridan will get higher annual rainfall than Powell will. That's why Powell in most of all these instances needs more overall moisture, right?
Right.
Did I take your presentation away from you, Jeremiah?
No,
Okay.
That's 100% what it is, you know. And so we're gonna, like with this presentation, we're really focusing in on the alfalfa and the grass pastures. So those first two top lines is what we're focusing on, and just want to illustrate that it's different for location. So in Sheridan, they estimate 23 inches of moisture through the growing season per acre. And so even though Sheridan might be in a moisture regime of, let's say, 12 inches, some of that comes in the form of snow. And that snow doesn't always get counted in the growing season, right?
Yeah.
And you hit it. Up here in Powell, we're hotter, right? We're lower precipitation. So we get 6 to 7 inches of moisture annually here. Of precipitation here in Powell. The other thing that is unique, and so just for Powell, as an example, our irrigation system, we have a very elaborate irrigation canals and canal work through the basin here, and we work under irrigation districts that administer those canals and distribute that water. Our irrigation season is from April 15th to October 15th. It is a rigid schedule. That's when the irrigation districts turn the irrigation water into the canals and shut it off. And so in essence, that's our growing season, because that's when our irrigation water is available. However, the benefit to us versus other parts of the state, we have an abundance of water. We have a lot of water because of the intricate irrigation canals and also the reservoir they built to store that water for us. That's not normal for all of Wyoming. So if you look at this, if you count up from April 15th to October 15th, that's 27 weeks. So almost an inch a week is what the demand of the crop is, a little bit higher than that. Thing to point out is just the other crops. They need it. They need different water uses. So corn, Jeff, we were just talking about corn in your high tunnel.
Right.
A mature corn plant. So where you're at, you're telling me that you're just starting to fill grain, I believe, correct?
Yes.
So a mature corn plant at that stage goes through a gallon of water per plant per day. That's a lot of water.
That is a lot of water.
That's just for one plant. Now think of 30 acres of corn. That's a lot of water. So anyway, we just first need to know how much. And just what I want people to take away from this is it depends on what you're growing, and your location dictates that demand.
Yeah, we don't need to confuse people with acre feet of water.
No, let's not get into math today. My brain's not ready for that. So let's talk about evapotranspiration a little bit more. How do we determine the crop demand? And basically, this is, again, nothing that stays constant or the same on any one crop. And so it really is determined on where you're located at, right? So relative humidity plays a factor into it. Temperature, air temperature plays a factor. Solar radiation, those bright sunny days, no clouds in sight, and it's just cooking the plants, right? That changes the demand of the water. And then also wind. And what it is doing is, this evapotranspiration, what they abbreviate to ET rates, are determined off of how much water evaporates off of the soil surface and also transpires through the plant. So evaporation is water sitting on a surface, so it may be the leaf surface or the surface of the ground, and that evaporates from a water to a gas, turns to water vapor, and moves into the air. also the plant is respiring water vapor, just like we do. When we breathe out water vapor. Just same with the plant. So evapotranspiration is quantifying that much demand of water. And so you can imagine in July, when we start topping 100-degree days, 110, whatever those temperatures are, bright, full, sunshiny days, that water demand is going to go up because of the loss of water through evaporation and through transpiration of the crop. Then you add the wind to it. And this is where those poor people in Casper, right, get a double whammy. Anytime that there's a wind, and it doesn't matter if it's a light breeze, but anytime there's air movement, that goes up as well. That ET rate demand goes up onto the crop. And then, of course, it's the reverse, right? So a cooler day, cloudy day, cooler temperatures, no wind, the demand on the crop is not as much.
Right.
So just to understand, that's how they determine how much a crop needs to utilize. The last factor of that is the crop itself. As that crop grows and matures, the water demand and need of how much water it needs goes up. So that makes sense. Little seedling plant this big versus, a 6-foot tall corn stalk, those water needs are going to be different. The other thing is, just like your corn plant, the grain fill period, once it starts setting seed or setting fruit, whatever the crop is and what it produces, once it starts doing that, the water demand goes up as well during that time period. So what that usually means for our irrigation scheduling is we need to irrigate more frequently to supply that water. So you're going to not see a constant 1 inch of water demand through the entire year. So that really gets us down to, when should I irrigate? And so I like to think of this in two premises. So there's two boundaries that we're going to play in with of when to irrigate. And so this chart hopefully captures that pretty well. And the top line there you can see is field capacity. And what that means is, how much water can the soil hold? So once you hit field capacity, you're going to have standing water, pooling water sitting on the surface, right? The opposite end of that, and what that means is, when there's water pooling, the soil's not going to take anymore.
In my country, to get a pooling water from a rain, it takes about 2 inches.
Wow.
My soil on my property is 92% sand. So
right. So it depends, right? And that's why we can't just give one answer for everyone. Yeah, that's incredible. And probably the puddles don't last that long once it does start pooling.
If it rains in the morning, by that afternoon, I can be out doing what I need to do out in the field.
That can be a positive in some instances.
It can be a positive, yes.
The opposite end of that is the permanent wilting point. And so when a crop gets stressed, water stress, there's a lack of water, it will start wilting. And the leaves will start drooping, and it'll just look kind of dried out. Once you hit it, there's a certain point where that crop will wilt, and it's called the permanent wilting point. Doesn't matter how much water you pour on that plant, it's not coming back. You've basically
will not recover.
Yep, you've killed that plant, or you've pushed it to maturity, and it's done growing for the year. So we're going to try and play and keep water between that in our soil profile, and that's what's coined as available water. And so we want to keep that water level above that wilting point, but also below field capacity. And you hit on it, Jeff, on this chart. You can see on the bottom, on the left-hand side there is sand, and on the opposite, on the right-hand side, is clay. And so that water availability and those field capacities and permanent wilting points change as you have different soil types. And another caveat, right, for Wyoming, our soils are extremely variable in certain areas.
Yes, they are.
So the larger that area gets, you don't have the same uniform soil under the entire field. And so thus managing that can kind of complicate things. So The other thing we wanted to just kind of talk about is water quality and water and soil quality as well. So you already kind of talked about it a little bit, Jeff. Down in your area, do you guys have any problems with water quality?
Not really. I know that there are some places in Goshen County where nitrates in the wells are quite high.
Okay.
But other than that, that seems to be the only issue that folks run across. And it can be mineralized, so it's a hard water. It can be a hard water.
Right. Yeah. And most of those like like what you're coining, that high nitrate level, and that can be a concern for like domestic use and municipalities. But for irrigation purposes, if we have nitrates in the water and irrigate our crop, that in essence is fertilizing our crop to a degree.
It's okay.
Yeah, as long as we don't get too much, right?
Right.
One of the bigger water qualities that you want to be concerned about would be salts. High level of salt content in the water, and that's variable across the state. And so you just have to get a water sample to explore that.
And Jeremiah, what are those salts usually consist of? You know, when we talk about salt, most of us think about table salt, right? But that's not what we're talking about. It's other micronutrients that are in salt form.
Yeah, so it can be a various array of salts. So even what is table salt is also in that water. So table salt is sodium and chloride. Mm-hmm. And so that can be in there. But we can also have various other different salts. So sodium, magnesium, right? I can't think of all the other ones, but there's various different compounds that formulate those salts. But the problem is when they get into high abundance in that water. And it's just something to be aware of, that water quality can be an issue and something to be aware of and concerned about with irrigation. But from my level of thinking, and it's more of what your soils are that are going to dictate if that water quality can become an issue for you or not. So you're always going to have salt in the water. It's just when you have high levels of salt. And there's even, so we hear about it in the oil and gas industry. There's actually water that is considered brine. And that means that it is so saturated with salt that it is falling out of solution.
Okay.
And so you can actually take a water sample and see salt crystals at the bottom or floating in that water sample because it is so saturated with salt. That would be a bad water to irrigate with.
I think I've actually seen that.
Have you? It's crazy.
Yeah.
But like, so, and we don't have this type of choice though. But if you could apply a salty water to a sand, it's going to flush, drain really well, and those salt particles are going to constantly be moving through that soil profile, usually not build up and cause a problem. But anytime we start getting into those finer textured soils, into a loam or into a silt or into clays, the closer you get to clay, the more that salt's going to build up. And thus you're going to have soil quality issues. And a lot of times people call that alkali.
And there are some irrigation strategies that can assist you in moving those salts away from the plant so that the plant can have access to the water.
Right. And one of the biggest ones that I know of, especially if you're doing a surface irrigation, is irrigating the amount of water you need to irrigate at one time, shut that water off. It's called deep soaking, trying to soak that and then allow a period of dry time. The longer you allow that water to sit on the surface of that soil, the more those salts will accumulate on the surface and thus near the plants and can injure the plants.
So Jeremiah, for folks that haven't done it before, how do they find out what type of soil they have or what their water quality is?
Oh, great question. Yeah. So there's two ways. So the water quality, you can send it off to a third-party analysis lab. You just take a water sample, send it into them. There's a few here in the state of Wyoming that can do a water test. Most of those do a water test for domestic use. I like to recommend an agriculture laboratory. So the two that I primarily look at is Colorado State university's plant and soil laboratory. They also do water tests. And then the other one would be Ward Laboratories. But there's other labs out there as well. But you'll send that off, send a sample. They'll send you back the analysis of that water. The same with the soil. You can do that too.
Usually the two things you're going to get back from a domestic well check would be nitrate level and E. coli level.
And possibly coliform. Yep.
Yes. Yeah, right. So if you want more in-depth analysis, I would contact the lab first, ask them to send you the correct sample containers, and then take your sample and send it in. And usually there's a time limit. You have to have it in within a certain number of hours to get it to read correctly.
Right, and keep it a certain temperature. Not precise, but keep it cool. It doesn't sit on a dash of a pickup truck for a week. And
wait a minute, you mean that's not good for water samples either?
Supposedly. Yeah, but no, I agree with you, Jeff. Call that lab first. Talk to them about how to get the best representative sample to the lab in a most efficient manner to get you the best accurate results possible.
Yeah.
In terms of the soil, you can send off for a soil analysis as well to those same laboratories, and they will, if you select the right analysis, they will tell you what type of soil you have. May it be a loam, a silt loam, whatever. There are also people that can do it by a texture by feel is what it's called. And so those are trained professionals. Our extension educators have that knowledge or have resources to help communicate that to you. Other ones would be like the NRCS office, BLM office, Weed and Pest may have that ability as well, just depending on their staffing ability and training. Conservation districts are another one to reach out to. They have some working knowledge of that too. And so that's not sending anything off. It's literally grabbing a piece of soil in your hand off of the property and feeling it, looking for grittiness, how well it sticks together, things like that. It's not the most precise method, but for somebody that does it on a regular basis, they're pretty adept to it.
Does it stick to your boots or not?
Well, that's what we used when I grew up as a boy. Yeah, we got in the gumbo clay, and that really mattered.
Yeah, exactly.
Yeah, but getting back to irrigation. So how do I know how much available water is in the soil? And these bullet points are just different ways people are doing it. And it really hinges on the individual property and your specific situation, right? So the first one is there are people that are, again, adept at reading the crop. They've raised that crop enough. They can tell just by looking at the crop, it's getting a little dry, I'm going to irrigate. Or, that crop's looking a little wet, I don't need to irrigate. And they can just tell by assessing the crop condition that they're growing. The next one is a feel of soil or irrigation by feel. And so we have a resource on that, and we'll put a link on the Barnyards Backyards website with this. But it has to do with you would dig down in the soil to a certain depth, say, 6 inches to 8 inches, and you would grab a bit of that soil out of there, and you'd feel it in your hand and try and you would need to know what texture of soil you have, but you would also need to see how well that soil clumps together and also holds together. And part of that, again, this is kind of a training. You got to kind of do this. It's not something somebody can walk out and just do right away. But that you're able to tell just by how well that holds together and how damp that soil clod is in your hand to say, this is where I'm at with water availability in that soil. The next level is district irrigation. Sometimes we don't get to determine what our available water supply is in our soil. Sometimes it's dictated to us by other means. And one of those might be the district irrigation. When the district gives me water, when it's my turn on the ditch, essentially, I get water and I irrigate my field. I don't have a say of when that water gets turned on and off. It just depends on your individual situation.
It's my week. I better get after it.
Right, exactly. The next one is personal calendar. Some of us are in a situation where we can actually irrigate to our time and our availability. And I think of this more like a lawn situation at our house where if you have a well or a way to just turn on a hydrant when you want it on and off, you go to work, you come home in the evening and irrigate. And so you can set that up to your own personal calendar.
Yep.
That's probably not the most common for larger acreages, is what I'd say. But that's out there. The last one is when the neighbor does, right? And so this is like in my situation on my personal property, I live in a subdivision area. We all have acreage and we have shared water. And so the district turns water into our subdivision, and then we have to share with our neighbors. And so it kind of goes back to that district irrigation. But when my neighbor's done using it, then it's my turn. And then when I'm done with it, the next person in line gets it. So it's really a coordination of other people. When do you need it? How long are you going to have it for? When I need it? And those are sometimes it really relies on that network of those neighbors and getting along with those neighbors and helping each other out as much as possible.
In my situation, Jeremiah, we're the last one on a leg of the ditch. So I have to really be ready for it when it comes.
Because you don't know when it's going to get shut off, right?
That's right.
So once you get it, you got to put it to use.
Yes.
The last one, and it might not fit really with our smaller acreage. So I'm, again, talking that 1/2 acre to 40 acre, and it might depend on crop, but soil moisture sensors, they're out there. I wanted to mention to them. They're probably not, they most likely would not be the most economical item to help manage water on a small acreage, especially if you're not producing a crop off of it. But what these are is they're a sensor that you install in your soil in the field, and you got to calibrate them within the field, and then you start irrigating and you watch on the computer and watch those numbers go up and down, and it tells you how much water is available in that soil. And so you can use them. They're useful, they're beneficial, but they are rather expensive items, and they take time to utilize out there. But they are useful. I see these mostly in commercial crop production, and especially in a high value crop. So dry onions, vegetables, seed production, those kind of things where these are high cash value crops. I typically don't see them in a hay field or an alfalfa field. However, they can definitely be used there.
We had some of these installed in raspberry production and strawberry production. And it was they were installed at 3 different heights in the soil profile. So it was really interesting to watch how efficiently we were irrigating using our system and when we had the water. So it's fascinating data.
And it's useful if you really truly want to use it. But it's definitely not at the level that it's going to just tell you, hey, you need to irrigate. It's kind of a micromanagement type system, fairly intensive system to just stay on top of and monitor. So that's why we don't see it in pastures as much.
Right.
So this is the next question that everybody wants to know about. When is the best time to what's the best irrigation system to irrigate with? And I hear a lot of times everybody's like, oh, you got to get a center pivot. Center pivots are what you need to have. Well, if you own 4 acres or 5 acres, you might not want a center pivot. You know,
that would be a 1 tower center pivot.
Right. And most of the time it might turn only 90 degrees. It wouldn't even do a 360. But size of the field does play a part of it, but it's also not the only determining factor. And so what is your current irrigation system? A lot of Wyoming's current or first irrigation systems ever installed were tarp and dam systems. So they're a dirt ditch that have a canvas tarp, and we'll show pictures of this here in a bit.
And it's also referred to as flood irrigation, right?
Right. Flood irrigation, wild flood, correct. Yep. And so that sometimes if you have an irrigation system and it's working fairly well, why change it, right? Maybe it might work.
The earthen dam type or tarpon dam, that is the least expensive irrigation method that you could go with.
Right. The other factor is field topography. So are you do you have a flat field? Does your field have a slope? Does it have some rolling topography in it? Are you on a hillside? That's all going to dictate a good irrigation system, or maybe irrigation systems that are a little more efficient for those fields. So surface water irrigation, so flood irrigation, those are hard to do on very steep topography because the water just rushes off of that very quickly and does not stay there long enough to soak into the soil. So yeah, well, the topography plays a part. How much money do you want to spend on improvements, right? Anytime you start installing bigger systems, more efficient systems, we'll talk about it in more depth here in a bit, but they can get pretty spendy. But then also, as you move away from that tarp and dam system, the cost of maintenance of those systems also goes up. So another factor everybody wants to play a part of is time available for irrigating. How much time do you have? Labor, you physically going out there, changing sets of water, changing the irrigation, how much time do you have? And that might dictate what you need to have. So and we're jumping ahead a little bit, but that's okay. But that dam and tarp system, that's pretty labor intensive. And that's why everybody wants to pivot on their property, is because I can push a button and it turns on like a sprinkler system. So
right. Especially if you're, if you're cutting waterways with a shovel, or if you're setting
right.
tubes, those types of things. People who move to Wyoming and you talk to them about setting tubes, it's an alien concept.
It is. Well, but if you need an exercise program, irrigating is a really good exercise program, because you need to be out there at certain times of the day, a lot of physical walking, moving, setting things, and it's on a schedule. So you kind of don't get a choice that now I'm going to bow out of this exercise program and sit on the couch. The other part is availability of the irrigation water. And so there are certain systems, especially once we get into sprinklers, they need a certain consistent supply of water to make them function properly. And so if you have irregular water flows, that can influence that and might make some irrigation systems null and void. You might not be able to even go down that road. So again, getting back to that manual, that small acreage irrigation manual, this is a chart out of that. I don't want to dwell on this and hit on it too much, but they have the different irrigation systems running down the left-hand side, and then different columns here to talk about it. But the big thing, and Jeff already hit on some of it, but the big thing you need to know as you work down the chart, typically as a general rule of thumb, it costs more to install that system. The price goes up fairly dramatic. So what they have here for flood irrigation for buying those canvas tarps, $0 to $20. But you get down there towards sprinkler systems, you can get up into the thousands of dollars per acre. And then surface drip is a lot of money. And so that's surface drip or subsurface drip. And so it's a drip irrigation system that's either on the surface of the soil or is buried in the soil. And Jeff, you have one of those, don't you?
Yeah, I actually have 8 acres that's subsurface drip irrigation, and the things that they're talking about there are very accurate.
It's expensive to put in.
Right.
Very expensive to run.
But it is very efficient. That's the best part of it, right? So it can be up to 95% efficient. All the water that you're putting into that field is actually going where it needs to go.
Right. So you're not losing a lot of that water either to runoff off of the field or to evaporation into the atmosphere, but that water is actually being put where it needs to be and being utilized by the plant.
Yes.
But there's can be problems or issues with that type of irrigation. Right?
Let's call them challenges.
Challenges. That's probably a better term.
Yeah. So the big one is filtration, right? That adds to the cost. Okay. My particular system, I have 2 big filters on it that they're self-cleaning. They're sand media filters is what they are. And so it's an interesting way to do that. But then if you have lines installed under the ground and you live in a place where there are gophers and plastic irrigation lines do not get along very well. So I'm constantly wandering around looking for places where gophers happen to be and then trapping them immediately.
Hopefully keeping them out of the lines themselves.
And then repairing
repair those.
Yeah. Yeah, and so you also, if your water's not running and there are gophers out there, they can go anywhere they want to and chew up any number of lines, and um, you might not be able to fix them until the following irrigation year, and you're in deep trouble.
Well, and it could be anything, right? Not only gophers, but there could be voles. A lot of those burrowing animals, ground squirrels, prairie dogs.
Prairie dogs, yeah. Fortunately, voles don't dig deep enough to actually get to it. The only time that would happen is when you installed it, because you have to actually plow the lines in, and if you don't get the lines buried over the top, voles may come in and chew on the lines before you're done.
Right.
So it's important to install it correctly.
And how deep are your lines?
So my lines are non-traditional. They're only 10 inches deep. They can be installed anywhere from 12 to 18 inches deep. And it's amazing to me, you know, in my brain, we think of water as always going down. But it's interesting because as we're irrigating, and I'll irrigate for 3 or 4 hours every single day. And what happens is it waters a zone around that pipe, and it goes up as well. There are places where I have water coming to the surface where I don't have plants using that water. So I can see exactly where the lines are at.
Well, and yeah, the other thing is mechanical, right? So if you put in a subsurface drip irrigation, you shouldn't plow, and you shouldn't do any tillage, physical tillage of that soil, may it be with a hoe or a shovel, unless you can do it shallower than the lines are ran.
Yeah. So, you know, at 10 inches, there are a lot of implements that don't actually go 10 inches deep.
Right.
And then traditionally, if you're 12 or 18 inches deep, you can plant it conventionally. You can do what you normally do, except
right.
ripping it, of course. That would.
Yeah, ripping a field would be a big tooth sinking, 3 or 4 feet in the ground, and yeah, you'd rip all those lines, and then you have to go back and replace it all, fix it. But anyway, so there's disadvantages. The other thing that this chart shows is working from the top to the bottom again, your labor demands go down, and that's why people generally like to get to sprinklers, to surface drip irrigation, is because it's less effort for me to go out and irrigate. It's closer to an automated system. However, I always like to throw the caveat out there. The more of a system you put in there, very much like what Jeff has, the closer you get to sprinklers in that system and more elaborate they are, the more maintenance there generally is with those, and thus you have a maintenance and repair cost associated also with running it and the purchase. So
right, you might not have the labor, the physical labor involved with irrigating, but you have other things that you're going to have to do.
Yep. And if you have enough money to offset that and pay for that, more power to you. So yeah. So I just wanted to go through so people have an idea what these different irrigation methods or systems look like. And so this is that earthen dam or canvas dam type irrigation system. You can see here that, let me see if I can get a highlighter. There we go. Can you see my pointer?
Yes, sir.
All right. So you usually have a ditch of some sort. Most of the time, the most that I'm familiar with in Wyoming are a earth ditch. They're just dug out of the ground and conveyance of that water. It could be a concrete ditch if they've been improved or anything that way. It doesn't have to be earth. But you have a ditch coming in, which would be your head ditch. You set up some type of dam system. Most often I see these as tarps or canvas tarps, and they set those in the ground in the ditch and back that water up, and it'll fill that ditch up, and then they'll come in and make some notches back through that ditch into the field, on the field side of that, so that water tips out of the ditch and runs into the field. And this is where it's called flood irrigation. And on top of it, it could also be called wild flood, because once it hits the field, it basically waters wherever that water goes, which plays off of the topography and contour of the land. And you don't really have control of that. It just, that's what it does. Oh, my laser. Let's see. I couldn't move my slides with the laser. So the next level for surface irrigation would be what is known as gated pipe. And so this is, this gated pipe is plumbed into your ditch, your head ditch coming in, and it captures that water, and that water runs into that pipe. And then the pipe has these different, what they call gates, evenly spaced out along the pipe. And depending on what type of pipe you buy, depends on what the space is. So the more I'm used to or knowledgeable are, they have a 20-inch spacing between gates or a 30-inch spacing. And the spacing has to do with what crop you're irrigating. But then you go along and slide the gates closed and open the gates you want. And you can kind of regulate flow to a little bit of degree per gate, because you can open it halfway, a quarter way, but it's not a very precise system. But you can kind of regulate how many gates are open, how much water is coming out of per gate. And so you get to a little bit more precise irrigation method.
So you don't have a picture of anybody setting tubes, Jeremiah? Oh, they're already there.
Tubes,
okay.
not setting tubes. But so these are called siphon tubes, and I probably should have done those after the tarp. But so the siphon tubes, they can be out of an earth ditch or out of a concrete ditch as well. And what they use is siphon. They're not powered. It's just like any type of siphon, like a straw, right?
Gravity flow.
Yep, gravity flow. You set it in the ditch and pop it out of the ditch, and it starts pulling water through gravity and through a siphon of that hose and pulls the water out of the ditch. And this is a regulation of how much water I'm putting in my ditch, and then how many tubes I set to keep that water at a constant level in the ditch without overtopping. One thing, and you can do this for any of these surface irrigation methods, but a method called corrugations. And so they will actually corrugate a field, especially with siphon tubes. It really plays a part with siphon tubes. But basically, it's a little trench that's pulled the length of the field, or basically from the headwater of the irrigation to the wastewater ditch, whichever direction that runs in the field, and they'll pull those corrugations. And what it does is it does a little more control of that water and assures a more uniform distribution of that irrigation across the field. And so like in siphon tubes, they'll pop a tube out in each corrugation. If they want more water, they might put a larger tube or two tubes running in one corrugation. You can do that with a canvas tarp, and to a degree, it will give it a little bit more uniform and controlled flow. But usually with our tarp and dam, that doesn't have much. We don't have much control of where that water goes. It works. They also do corrugations, or you can do corrugations off of gated pipe as well. And that just does a very efficient job of getting that water uniformly across that field to soak. So that's surface irrigation.
One of the things they use in our area on gated pipe is what they call socks. And it's a wire frame and a fabric mesh that goes over the top of the opening, the gate, and keeps the water from eating away or eating large holes, eroding near the pipe. So it keeps our sandy soil in place.
Yeah, well, I'll have to go out and get one of those, picture of that, and pop it in this presentation. That's a good point. And it can happen in a lot of them, right? So especially the siphon tubes and the gated pipe, a lot of times you have a large volume of water flushing right there out of those exit points, and it does a lot of washing on our soils. And so that sock kind of slows the velocity of that water down to hopefully hold that soil so we don't dig holes right there where our water's tumbling. Yeah. Thanks for bringing that up, Jeff.
Sure.
The next step up is sprinkler. And I mean, depends on how elaborate you really want to get. There's various options of sprinklers out there. So the one on the top left is a big gun sprinkler. You usually see these with golf courses. That's where I mainly see these. But they're put on a big hose reel. And in a way, again, we have control of the sprinkler head, like how much volume is being put down. But then also we get uniform application for the field. So they will actually grab that little sprinkler cart drag it out away from the reel, and the reel will slowly reel that cart back into it, so it has a uniform application through that whole area that you set it.
So if people need to compare this to something, it's like a lawn tractor,
Yeah.
only in reverse, right? The water
Correct.
drives the lawn tractor. This thing, the water drives the reel and pulls the whole sprinkler head back to it.
Right. Well, and it's ran on a pump. So you need quite a bit of volume of water to run this, and have a pump that is appropriately sized to run this. They're usually sold as a unit.
Yeah.
And so they work really well. I have seen this on some pastures, and these are really nice, especially for irregular shaped fields, right? They're not the rectangle field or square field. These work really good because you can pull them as far as you want, or in different little areas, or just set it and let it sprinkle. So it works really good.
There's a producer between Laramie and Fort Collins who uses it to grow corn in a really weird shaped field.
And they work great there. They're
Yeah.
excellent. But you can also, I've seen them in a rectangle field too. And so they work well there as well. The next one is this top right. This is called hand line. And it's a little hard to see the pipe, but there's a galvanized pipe, it's not galvanized, it's aluminum pipe that lays on the soil surface. And then it has these risers every so far, and it has a birdie on them, which is the sprinkler that you actually see above the ground. And you set that hand line, hook it up to your water source. Again, if you have enough gravity flow, it could run off of gravity flow. But if you don't, you'd have to use a pump. Generally speaking, this hand line is meant to be moved. And so it gets moved in 30 to 40 foot chunks of pipe that have these birdies already installed. And you'd move them across the field physically and hook them up to your water supply. I've seen some situations where they're either small enough acreage, or they've just bought enough hand line over the years that they don't move the hand line. They just move the hose that attaches it to their water source, and makes it a little easier. But
right.
Again, a really good exercise program. The one here on the bottom is very similar to the hand line. There's different words for these. These are the pod system. I think there's a company calls them the K-line system, things like that. But inside those little donuts or tire shaped pods is a sprinkler head. And the concept behind this one is you string it out like this, you set it, hook it up to your water supply, and water, and it irrigates and does a pretty good job. Usually this one runs off of a pump, to my knowledge. I don't think that we usually get into systems that can run it off of gravity flow, but you'd have to look into that. But the benefit of this one that I've heard advertised is you hook onto it with your ATV and drag it to the next spot, right? So you unhook it from your water source, hopefully, hook on with the ATV, pull it over, rehook it up, turn it on, and it runs really, really well.
Less labor,
right? And we get to use a toy. Everybody loves toys. So, but you were saying that you had talked to an individual that uses this, and they ran into a little bit of a problem with it.
Yeah, so he really liked it, but then he got into a point where he was going to have to cut his pasture and bale it and get all that biomass off, because he got to a point where he couldn't drag it anymore. So, so the pasture grass, the grasses need to be fairly short as you're dragging it around.
Oh, that's good to know. And that's what I see with it. It's so low to the ground. You can see with the hand line, the sprinklers are up off the ground. So as that crop grows, with that sprinkler being so close to the ground, the crop can actually impede where that water is distributed, and you might not get a good uniform application.
Right.
I have seen these systems more in a grazing rotation. And so there is always following cattle that have grazed off an area. And so then it has that short grass to it. I have not seen it work real well, or doesn't seem to lend itself to a hay type system if somebody was to put up hay. But that's good to know, especially anecdotally. the last two, and I didn't put in a subsurface drip irrigation. You wouldn't see it. I'd probably have to find a diagram to have a better illustration of it. But I think Jeff covered it.
I could go dig a hole and show it to you.
There you go. But the last two are, the one on the bottom is called side roll pivot. It's again it's the same aluminum piping that they do for the hand line. However, they've just mounted wheels to it, so it'll actually roll in the field. But this is set up. It has a tractor, is what it's called. It's in the middle of the pipe, and that is ran on a gas motor, and it rolls the entire section of pipe for you. And then once you get it to where you want, you stop, turn it off, and hook it up to your water source. And so it stays fixed in location and irrigates, and then you move it between sets with the tractor. So it's not a walking sprinkler, if you will, or a moving sprinkler. Then the last one is at the top is a center pivot. The Cadillac of irrigation systems, right? So this they have two different methods of irrigation systems with these. So they can be a lateral pivot, so they will actually move back and forth on a field and make a rectangular field or fit a rectangular field. We are more common and used to a center pivot, which has a pivoting point, and the pivot moves around that pivot, making a crop circle or a half circle, quarter circle, whatever.
Yeah, so there's a lateral probably at the Powell Research Station, right?
Correct.
There's one at the Lingle Research Station. And apparently, because it's small plot research, they can modify the flow to each one of the sprinkle nozzles to deliver the right amount of water, right?
Correct. Yeah, so you want to talk about toys. Center pivots have the toys, right? So you can upgrade infinitely, it seems like, on these pivots, but you can run them off of a smartphone. So you don't even have to be present. You can turn them on, stop them. I still recommend you go check them, right, to make sure you don't have any plugged nozzles or any mechanical issues. They also are ran by GPS, so they can do zone irrigation on like pie wedges out of the field, so they can irrigate heavier in one spot and less in another. The recent upgrades right now for pivots are going to, like what you're saying, Jeff, they can control how much volume of water is coming out per sprinkler head. They can turn sprinkler heads off individually. They could do it by tower, from tower to tower sections. So, and that all just, the cost just goes up and up with all those improvements. But
the reason that you would want some of those types of things, or think that you want some of those types of things, is to accommodate the correct water usage in the different soil types, right?
Right. So if you have a extremely variable soil conditions in your field, there's some that have 5 to 8 different soil types in their field, and they're trying to balance that so they all are uniform. They all get the appropriate amount of water. The sands get more water, the clays get less water, the loams get average, and just regulate that water throughout the field. Yep, definitely. So they're pretty cool. The other thing, we kind of comes full circle now, right, with our irrigation.
No pun intended.
No pun intended, right? But we start with surface irrigation, right? And everybody's building and working and wants to have the sprinkler system because it's more efficient, more precise. We have more control of our water. Currently in the irrigation world, these center pivots are now trying to figure out how to not sprinkle water, but to apply it to a surface water application for various reasons. So they have actual hoses that they drag on the soil surface and don't have birdies that sprinkle down. So it's an ever evolving and changing. Even though irrigation is an old practice, we're still trying to find new ways and better ways. And so there isn't a perfect, ideal irrigation system. There's pros and cons to all of it.
My biggest question about center pivot is, if you're never going to grow corn, if you never have any intention of growing a tall crop, why are the center pivots so tall?
I'm not really sure. So there are short ones.
So Jeremiah, have you ever had to go clean out nozzles?
Yes.
It's, if they're eye level and lower, it's okay. But when they're up here,
Right. When you need a ladder or to stand on the truck hood to do it,
yes,
the top of the truck cab to do it. Yeah.
yes, yeah, you're going to get a soaking.
Right. Well, they do make shorter pivots to where the towers are like the pipe. You can touch it. It's like 7 foot off the ground.
Which would be perfect.
Right. But generally most towers are taller. They add more flexibility to them. You get a larger spray pattern usually, depending on what crop's under it. A lot of them have drop down hoses, and so you want those sprinklers at a certain height dependent on what crop you're irrigating. It's all variable, right? And they are all changeable. I've even heard of some systems and some producers where they'll put drop nozzles pretty close to the ground for the crop, and they'll have 2 or 3 movements up that drop tube and raise that irrigation up as the crop grows. I have not heard anecdotally from them, but I don't see that very often. I mean, it's rare. And for the few that I heard of, one guy that thought about doing it, and he was like, "No way, that's way more labor than I want to do. Why do I have a pivot if I'm going to do that?"
Right, I might as well be flood irrigating.
Right, but that's a good point, though, Jeff. With all of these systems, gated pipe, sprinklers, center pivots, you want to calibrate them. You want to know how much water is actually being applied on the ground per a set time period, 15 minutes, half an hour, whatever it is, because parts wear out and you'll get more or less water because of it, or they get plugged or whatever. And so with center pivots, some of that variable is how far those nozzles need to be off the ground for that crop. So that's something to ask somebody about, definitely.
Yeah. One of the things that my wife and I talk about as we're driving the country, it's like, oh, that guy needs to go clean his nozzles.
Yeah. When you're in our line of work, Jeff, you just spend the time driving, looking at everybody else's fields and go, oh, they got a problem. Ooh. I was recently out driving some fields, not here in the Bighorn Basin, but we were driving, and they, on their hand line, they'd blown one of the birdies. So the water was shooting straight up in the air like a geyser. And it was like, oh, that one needs fixed, right? Like it's interesting to see.
Need a little repair job.
Yep. So, but with that, that's all I have for today. So, if there's, I don't see any questions on my end. Jenny, do you have any there on Facebook?
I don't think so.
Good.
Mm-hmm. Well, great. I guess we'll just close it up. And, I appreciate the time, and thanks for having me on the show and all that. And just wanted to roll it up for everybody. If you're on the Barnyards Backyards website, we've mentioned it several times. You'll want to log on there. And if you want to see future shows, we still have a schedule. We're still going on through the summer. So catch up with us when you can. Also, for shows like this one, we're recording them. We edit them slightly, just cut off the yakking at the beginning, basically, and throw them up there as well. So you can reference them later and watch them later, share them out. And we also put some links. So those publications we talked about and other resources, we try and link them directly there. So it's a one-stop shop for you guys. The next thing, your county extension office. We mentioned those resources. Our county extension office, we have one in every county of the state and one on the Wind River Indian Reservation. If you have questions about irrigating or want to get some of those publications, we do have some of those in a hard copy. Maybe not everywhere. Just depends on if we ran out yet or not. But reach out to your extension office. They could help you. The last thing is, and then Jenny's showing it here. We have a tab on the Barnyards and Backyards website that is specifically on water and irrigating your small acreage. There's the guide there, getting started, general questions. So a plethora of resources for you there. The last thing I'd like to throw out there is, as we do this show, we are always looking for feedback of how to better improve the show and make it specific for you. And what are you getting out of this show? We want to learn and hear from you. So if you have a chance to give us an evaluation, we appreciate it. Jenny has thrown the link to the evaluation in the chat box and then also on Facebook in the comments section. So if you have a chance to click that, we'd appreciate it. For those of you that have joined us via Zoom, you will be prompted in an internet browser when we're done, and you'll be able to quickly fill out that survey. I think it's like 5 questions, isn't it, Jeff? It's real short.
So, yep.
So, but with that, thank you so much for joining us, and we'll see you at the next show. Thank you, Jeff.
Thanks, Jeremiah, for being our guest. Thanks, Jenny.
All right, bye.